In the distant reaches of our solar system, a titan reigns, a world that has long captured the fascination of astronomers and dreamers alike. This is Jupiter, a gas giant so immense it could fit over 1,300 Earths within its vast expanse. But beyond its size, beyond its iconic bands of clouds, and the mighty Great Red Spot, lies a deeper mystery. A world that seems to hum with energy. Its storms are not just turbulent weather. They are the very heart of a complex and dynamic system, one that has continued to evolve and surprise us for centuries. Now, through the eyes of one of the most advanced telescopes ever created, we're able to peer into the heart of this celestial giant like never before. The James Webb Space Telescope, a marvel of engineering and innovation, is unlocking secrets about Jupiter's atmosphere, its storms, and its magnetic environment. Secrets that have been hidden from our view for centuries. What Webb is showing us isn't just a glimpse of Jupiter. It's an entirely new way of understanding how planets, with all their complexity and chaos, interact with their surroundings. The James Webb Space Telescope is designed to peer across the universe, gazing deep into the distant cosmos to reveal the first galaxies, the birthplaces of stars, and planets around far-off suns. But one of its most astonishing powers is its ability to see in the infrared spectrum, a capability that allows us to look beyond the clouds and into the heart of objects and phenomena that are invisible to the human eye. By focusing its infrared gaze on Jupiter, Webb is offering a fresh perspective on a planet that has already been studied extensively but remains filled with enigmas. Infrared light reveals the temperature variations in Jupiter's atmosphere, the heat signature of its storms, and even the faint glow of phenomena that are too subtle for visible light to capture. It's like opening a door to a whole new world, a world where temperatures, cloud compositions, and atmospheric dynamics can be studied in extraordinary detail. Among the most striking revelations is the clarity with which we can now see Jupiter's infamous Great Red Spot. This storm, a feature that has been raging for at least 350 years, is a powerful vortex that dwarfs Earth in size and has long baffled scientists. Webb's high-resolution infrared images provide unprecedented detail, showing not just the size of the storm, but its internal structure and heat emissions. The intensity of the heat within the Great Red Spot is far more complex than previously thought, suggesting that this iconic storm may be driven by forces that we're only beginning to understand. But it's not just the Great Red Spot that has Webb scientists excited. Through its infrared observations, Webb has revealed subtle details of Jupiter's atmosphere that were invisible to past missions. Webb can see the temperature variations across the planet, from the highest cloud layers down to deeper, more turbulent regions, giving scientists insight into how Jupiter's atmosphere works from top to bottom. These observations could provide new clues about the underlying processes that power this planet's violent weather systems and how they have evolved over time. And then, there are the auroras, phenomena that have fascinated observers for centuries. Jupiter's auroras, visible at its poles, are a mesmerizing display of charged particles colliding with the planet's magnetic field, creating brilliant bands of light. But Webb's observations are revealing something even more extraordinary. In infrared light, we're able to see the full extent of these auroras, tracing their patterns, their intensity, and the way they shift with Jupiter's complex magnetic environment. What makes Jupiter's auroras even more compelling is their connection to the planet's massive magnetic field. Jupiter's magnetosphere is the largest and most powerful in the solar system, stretching millions of miles into space, and it is deeply intertwined with the behavior of its atmosphere. Webb's infrared data provides us with a clearer picture of how the magnetosphere interacts with the atmosphere, fueling the auroras and shaping the weather systems around the poles. These observations may help us better understand not just Jupiter, but other magnetically active planets across the universe. Could similar magnetic forces exist on exoplanets, and how do they influence the atmospheres of worlds far beyond our own? Jupiter's moons, too, hold their own mysteries. Moons like Europa, with its icy surface hiding a vast, subsurface ocean that could harbor the conditions necessary for life, and Io, a volcanic world with the most active volcanism in the solar system. Webb's powerful infrared instruments allow us to study these moons in more detail than ever before, shedding light on their surface temperatures, their geologic activity, and their potential to support life in ways we've never before imagined. Europa, in particular, is a world that holds tantalizing clues for the future of space exploration. Beneath its frozen crust may lie a liquid ocean, and Webb's data could help us locate the most promising areas for future exploration. As we look at these moons through Webb's eyes, we begin to understand how Jupiter's gravitational pull and its intense magnetic field influence the environments of these moons, potentially creating conditions that could support microbial life or other forms of unknown biology. And beyond the Great Red Spot, there's a whole new world of storm systems. Webb has captured small cyclones and vortices, storms that are born and fade away in a matter of days. These short-lived features are difficult to study with traditional telescopes, but Webb's ability to observe temperature shifts and atmospheric changes has given us a closer look at how these smaller storms form, evolve, and dissipate. These fleeting cyclones are not just beautiful to observe. They hold important clues about the atmospheric dynamics of Jupiter. By studying how these storms behave, scientists are gaining a deeper understanding of the broader processes that drive weather systems on gas giants. This knowledge is crucial not just for understanding Jupiter, but for our studies of exoplanets and other gas giants that might exist around distant stars. With each new observation, Webb's data brings us closer to understanding the forces that shape Jupiter, one of the most dynamic and mysterious worlds in our solar system. The science team back on Earth is working tirelessly, analyzing the data Webb continues to send back. Their discoveries could revolutionize our understanding of gas giants, magnetic fields, atmospheric storms, and even the very nature of planetary evolution. And as we continue to uncover more about Jupiter, we are reminded of how little we truly know about the worlds that lie just beyond our reach. Each new piece of data, every image Webb sends back, opens a door to a new world of questions, of possibilities, and of wonder. What can we learn about the formation of our own solar system? What can Jupiter teach us about other planets, both in our own neighborhood and in distant star systems? Jupiter is not just another planet. It is a living, breathing testament to the complexity of our universe. Through Webb's eyes, we are witnessing a new era of planetary science. And as we continue to explore the depths of the gas giant's atmosphere, its auroras, its magnetic field, and its enigmatic moons, we are uncovering clues that may one day change our understanding of life itself. The mysteries of Jupiter are far from solved, but with the James Webb Space Telescope, we are closer than ever to understanding them. As Webb continues to reveal more of this giant's hidden secrets, we are reminded of how much still lies ahead for humanity. The universe is vast, and there is so much left to explore. Jupiter has been a guide, a beacon in the night sky for millennia, and now, through the power of Webb, it will continue to inspire and push the boundaries of our knowledge for generations to come.